Our last topic for study in this course is going to be the topic of atomic physics. Atomic physics is the study of the particles that make up all of the stuff in our universe. In some cases, it's particle physics, and in some cases, it's a little bit more, and we start looking at the interactions of those particles. But for the whole time, we're going to be looking at what things are made of. So I want you to consider this little Lego boat here. If I was to take this little Lego boat, I can see, okay, just, it's boat shaped. It kind of looks like it's on top of water. It's a boat. But if I wanted to know more about the boat, I would have to take it apart. And so I can see it's, I've got a couple of these pieces here. I've got a windshield. There's a brown 3x2. Here's another brown 3x2. Those are similar. Those are similar. This one's kind of off on its own, etc. And I can go ahead and just kind of systematically break this boat down into the parts that make up the boat. And when you do that, you can see that some of the parts are similar, and I might have more than one of the same part, and some of them are very different. I got a third one over there. And this is a really good analogy for how atomic physics works. We're going to be looking at how large objects like you and me and tables and cars and whatever, how we can break them down into their most fundamental parts. And it doesn't matter whether you are using, this small handful of parts or whether you have a lot of other parts that you could be working with. Everything in the universe can be broken down into a certain number of parts, and atomic physics is the study of how those things break down. So before we can start talking about atomic physics, we have to discuss this thing called the atom and how atoms kind of work together in order to build everything that we have in the universe around us. So let's kind of go ahead and discuss what an atom is. So if I leave myself just worried about atoms right now, an atom is the smallest individual building block of matter in the universe. So it is the smallest unit in the universe that still has its own identity. Its own identity. And what that means is that when you start working with anything that is smaller than an atom, you start losing a sense of what that object actually is. So, kind of going back to my Legos example, let's say I have this red Lego brick right here. This red Lego brick is it's 4 long, 2 wide, so it's a 2x4 Lego brick. This has its own identity. I can say this is a 2x4 Lego brick. Every 2x4 red Lego brick looks just like this. If I was to take this thing and smash it with a hammer into smaller pieces, those smaller pieces no longer have their same identity. I would have to put them back together in order to get back to my identity as a 2x4 Lego brick. So there is ultimately a smallest size that we can break things down to, and that is what atoms are. They're the smallest thing that we can possibly work with. Now, that doesn't mean that atoms aren't made of things. It's just that those things no longer have identities of their own. So when we talk about atoms, there are 3 particles that you need to keep track of. And this is going to be review for most people, but we have protons. Protons are positively charged, and they also are the thing that provides identity to the atom. And they are positive charge. We have neutrons, which for the most part just kind of hang out. They have 0 charge. And we have electrons, and electrons have a negative charge. So they have a negative, oops, that was redundant. They have a negative charge, so I've got my positive protons, which give my atom its identity. They have a positive charge. We have our neutrons, which have a neutral charge, or 0 charge, and then we have electrons, which have a negative charge. And when we start putting these things together in atoms, what we find is that my protons and my neutrons hang out in the middle of an atom, in what's called the nucleus, and that my electrons hang around outside of the atom. So this is where my electrons go. Now, a lot of models that you will see for atoms have the electrons kind of spinning in circles or whatever. They don't really do that. It's just a very convenient way of us to think about how they work. So if I was to go ahead and start substituting in some Lego pieces here, let's go ahead and I'm going to use red Lego bricks for my positive protons. I'm going to use yellow Lego bricks for my electrons on the outside. And I'm going to go ahead and use my blue Lego bricks to represent neutrons, which are still in the nucleus. And I've got 2 neutrons in this model. So I have my model for how atoms work. I've got my electrons on the outside. I've got protons and neutrons in the middle in a structure called the nucleus. And what I said before is that protons give identity to the atom, which means if I count up my number of protons, 1, 2, 3 protons, I can use that to figure out what the identity of this atom is. So once I know that I have my 3 protons, I head over to something called the periodic table, which I've got a copy of it on my phone. It's not showing up terribly well, but most of you know what a periodic table looks like. And I can find the element that has 3 protons in it is called lithium. So I know that this atom is a lithium atom. It's Li. So I've got 3 protons in my lithium atom. Now, one of the other things that you'll have to know for atomic physics is that protons and neutrons, the things that exist in the middle, they have mass. They are what makes an atom heavy. And electrons on the outside do not have mass. They are so small that we basically say that they don't have mass, because to try to count it up, there's not enough electrons for it to make a difference. So I know that I've got 1, 2, 3, 4, I've got 5 atoms in my, or 5 particles in my nucleus of lithium, so that I know that this thing has a mass of 5. This is an atom of lithium 5. And there's atoms of lithium 4, there might be an atom of lithium 6, but this one specifically is lithium 5. So we're going to go ahead and take this and we're going to recreate this in what's called nuclide notation. Nuclide notation is a quick and easy way for us to describe what atom we are looking at. So let's go ahead and take our atom of lithium 5 here and transfer this into nuclide notation. Let me go ahead and pick up my particles. They'll be back later, don't worry. So if I wanted to talk about lithium 5 as a nuclide notation, what I would do is I would start by identifying that we are indeed dealing with lithium here, so that's Li. I know that my lithium has 3 protons, and I know in this case I had 5 total items that made up the nucleus. So this is lithium 5 in nuclide notation. So this is my number, this is called the nucleon number. And it's basically the number of things in our nucleus. This down here is what's called the atomic number, and this tells me my number of protons. Because like I told you, protons give identity to an atom. So the number of protons that I have indicates what type of atom I'm dealing with. So if I come back, I can see that I've got 1, 2, 3 protons here. I know that I have a total number of 5 things in the nucleus, which means I need to have 2 additional things in the nucleus. So there's our atom that we have. Now you might be observant and say, hey, there's none of my electrons aren't mentioned in nuclide notation. And that is usually true. So let me give you an example of a place, or a lithium 5 atom that might have the electrons in the nuclide notation. I'm just going to set those aside for right now. Let's say that this was lithium 5 positive. So draw a box around this so you can kind of see what I'm working with here. So this is now lithium 5 positive. What lithium 5 positive means is that this positive thing means I have one more positive item than negative item in my atom of lithium. Now I know that I've got protons, and these are positive, so I've got 1, 2, 3 positive protons, which means if I've got one more positive thing than negative thing, I know I've only got 2 electrons in this atom. So this is how you read nuclide notation. You're going to see the atomic number on the bottom. The number on top tells us how many things we have in our nucleus. So usually if you take this top number and minus the bottom number, that tells me my number of neutrons. And if it has a charge on it, whether it's positive or negative, that can tell me how many electrons I have in my atom. So let's go ahead and take all of this and see if we can do a worked example together. So we're going to go ahead and do an atom of carbon 14. Carbon 14 is a really important atom that we use to figure out how old stuff is, because it gradually decays into its younger brother, carbon 13. We will talk about radioactive decay next week and how that works. But anyway, let's go ahead and see if we can identify a neutral atom of carbon 14. So, first thing I'm going to do is I'm going to go ahead and put it in nuclide notation. I know I've got carbon, and I said that I have 14 items inside of my nucleus. And if I take a look at my periodic table, I can see that carbon has 6 protons. That is that number in the upper left-hand corner of your periodic table. So I know that I've got 6 protons in carbon. And since I said this was a neutral atom, it doesn't have a positive or a negative charge, I'll know that I have the same number of electrons as I have protons. So let's go ahead and see if we can build this thing together. So I'm going to go ahead and start. I'm going to designate an area for my nucleus. And I know that carbon should have 6 protons inside of it. 1, 2, 3, 4, 5, 6. Okay. I should have made my nucleus bigger. Okay. I also know that if I'm dealing with carbon 14, if I have 6 of these items, or 6 protons, and I need to get up to a grand total of 14 items, that means I need 8 protons. So I'm going to go ahead and just start sticking stuff together here. There's 1, 2, 3, and just like in real life, protons kind of act as the glue that holds a lot of this stuff together. 4, 5, 6, just start sticking stuff together, 7, and 8. Okay, so I have 14 Legos that make up the things in my nucleus. 6 of them are protons, the other remaining 8 of them are neutrons. And since I said this is a neutral atom, that means if I have 6 protons, which carry a positive charge, I now need 6 electrons, which are the things that carry my negative charge. And so I'm going to go ahead and kind of distribute these. Remember, electrons have a negative charge, and if you put 2 items that have the same charge together, they naturally repel. So electrons try to spread out as far as they possibly can. And that might leave you asking the question, but protons all stick together in the middle. Why is that? That is because of something called the strong nuclear force, which is one of the fundamental forces of the universe. It is also something that we don't necessarily have to go over in this course. So for right now, just take my word for it that the protons don't naturally repel each other and fly in a million different directions. So go ahead and counting my things up. I've got 6 protons. I've got 8 neutrons, which gives me a total of 14 objects in the middle of my atom. I've got 1, 2, 3, 4, 5, and 6 electrons, which means I've got 6 negatives, and I've got 6 positives from my protons, which means our thing is neutral. So what I have created here is definitely an atom of carbon 14. So that is how you can go ahead and build an atom. So we have our stable carbon-14 atom. Now the question becomes, what happens if I add or remove something from this atom? How does that change? So the first thing that we can do is, if I was to add another blue Lego, remember these represent our neutrons. If I add another neutron onto the Lego, onto my atom, remember it's in the nucleus, I now have still 6 protons, but now I have 9 neutrons, bringing me up to a total of 15 items in my nucleus. This is carbon-15, and carbon-15 and carbon-14 are what are called isotopes. Isotopes are elements of the same, they're atoms of the same element that have a different number of neutrons. Sometimes they behave differently. Some isotopes are stable, some isotopes are not stable, but they're fundamentally the same thing, with just that small change of having extra neutrons. It's kind of like if you know a pair of twins, they're fundamentally the same like structure, but they might be just ever so slightly different. Twins are like isotopes of people. So we've got our isotopes. We're now dealing with an atom of carbon-15. If I was to add an extra electron onto this thing, I now have 1, 2, 3, 4, 5, 6, 7 electrons and still 6 protons. I've got 7 negative things. I have 6 positive things, which means I now have more negatives than I have positives. This is now carbon-15 negative. So that changes the charge on this thing, and that is what's called an ion. An ion is an atom that has an electrical charge, whether that's positive or negative. If I wanted to give this particular atom a positive charge, I have to remove electrons from it. So in this case, I now have 5 electrons. I still have 6 protons here. This would be carbon-15 positive or carbon-15 plus. Now, you might find yourself asking, well, couldn't I have just added an extra proton to it? So if I was to take this thing, and here's a proton, I can add another proton to it. I'll stick it on there. I now have 1, 2, 3, 4, 5, 6, 7 protons. This thing is now no longer carbon. You might remember that I said protons give atoms their identity. So if I go over to my periodic table, I can see that something that has 7 protons is no longer carbon. I've now changed this thing to nitrogen. So if I was to go ahead and make that change here, I have nitrogen with 7 protons. I still have 5 electrons. So this is going to be nitrogen with 2 positive. It's more electropositive than it was before because there's more positive things than there are negative things. So those are isotopes and ions. So little changes to the atom can change how it behaves. This isotope of nitrogen is positively charged. It would be attracted to something that's negatively charged, kind of like when we talked about electrostatic electricity. But if I take a proton away from this thing, I can switch this thing back to carbon. And so adding and removing protons changes what element we're dealing with. And if I was to go ahead and take off a neutron here, that changes my isotope. So now I'm back to carbon-14. So if I change my number of neutrons, that gives me a change in isotope. If I change my number of protons, that gives me a change in element. And if I change my number of electrons, that gives me a change in ions. Hopefully this made sense. I know there's a lot of information coming at you very quickly. Some of this will be review from previous science classes that you've had. I would really encourage you to take a look at the extra material that I've posted for this week. It explains it just in a different way, and hopefully that will help you out with doing the assignment. If you have any questions, feel free to visit me in office hours. Otherwise, have a great week.